In my first opening video, I said I was going to dedicate the mini machine shop to the mini mill and the mini lathe, but I realized that I never done an introductory overview of the mini mill. This happens to be the Grizzly. No particular reason other than I bought the Harbor Freight mini lathe first and saw and worked with the quality of that. I went to Grizzly hoping that it was going to be a little bit better. I believe they're all the same. They all come out of the same factory, no doubt, in China. They're all going to be unique. Some may have a problem with a slide, some may have some other problem. You might get the luck of the draw. Harbor Freight here does not carry this particular mini mill. You'd have to order it and pay for the shipping. The Grizzly also, keep in mind that this is a 149 pound mill and it costs you basically $79 to get it shipped. $79, it pays for a lot of gas. So you could go to Harbor Freight and ask them to see where the closest store is that actually has it in stock before you order and pay for something. Once you get it, also with Grizzly, keep in mind they give you all kinds of warnings that you have to get it off the delivery truck. Luckily, I think my delivery truck had a hydraulic gate and had a dolly to be able to get it in the garage for me. I think all of them are going to have a hydraulic gate so they can deliver it. But once you get it, you're going to uncrate it and then you're going to do whatever you can to get it up on your bench. You can either ask a friend or somebody to help you, or like me, I was alone, and so I undid the big bolt back here and separated the whole vertical section here from the table. If you're going to do that, be very, very careful. This is a 120 pound kind of head here, and when you loosen that bolt, it's going to want to go one way or the other real quick, so you better be prepared to hang on to it. Then once you get it up on your bench, first thing you're going to do is degrease it. It's going to have grease all over the place. Take your time, get it cleaned up. Once you have it cleaned up, I know you're going to use gasoline, paint thinner, something to get it off. You're going to want to put a light film of motor oil on it to keep it from rusting. Now that you've got it up here and you've got this bolted together, do the best you can to figure out the tilt. Later on, you'll fine tune it to get it just where you want. There is the ability through the nut, and there's no other better way to adjust the tilt than just have the nut kind of loose and you bang and hammering to get it that way. There is no adjustment for forward and backward. So, like I said, this is a very heavy head, and this is cast iron, which is hollow. It's going to bend, and on all of them, including this one, it was tilted forward, but I'll show you how to correct that. Once you have it degreased, the first thing you got to do is check the head and the gibs. There's three gib screws on the side that tighten and loosen a gib that rides in this V-slot on this side. You want to make sure, and it's hard because of how heavy this is, that you're not sloppy this way. You have to get this adjusted just right. First thing you do is I would tighten up one of the end screws, end gibs, until you feel some friction, and then back off slightly. Do the other one, then back off slightly, then do the middle one. Once you're sure that you have this adjusted and no play in it at all, and it's very hard to do, now you want to start playing with the table. This is the x-axis going this way. This is the y-axis, and of course this is the z-axis. You want to do the same thing to the table. You want to make sure there's absolutely no movement at all in the table by playing with the gib screws. If you can't get the play out of it, then you've got something wrong. You may have a defective gib, it may not have been machined correctly, you may have a problem with the table, but don't really start milling or playing around until you have the play out of it. the play too is also going to be dependent upon what you bought the machine to do. If you're going to do extreme precision work, then you need all the play gone. If you're just going to cut some things here or there, drill with it, then a little bit of play, a few thousandths, is fine. On this handle, when it's shipped to you, it's going to be pushed in. And so this knob is going to control your Z-axis. It took me a long time before I realized you could pull this out. It was really, really tight in the beginning, and now you can simply go up and down. Okay, now that you've got it cleaned up and all the play is gone from the table and the Z-axis, let's go over basic operation. Your mill may come with the chuck pre-installed, it may not. This is the chuck right here. So it goes all the way up to a 1/2 inch, and it's a pretty good chuck too. It's got very little run out, which is wobble in the jaws when you clamp something. If it's not in there, your mill will not have this. This is an upgrade. You will have this cap though, and it will be snapped in place. Remove the cap and it will reveal the drawbar. What you do to either insert or remove the chuck is you will be supplied with one of these that you'll stick in the side here, and you'll rotate it until it falls into a hole, locking the spindle. Come on, where are you? Not there. Here it is. There. The spindle's now locked, and you can unscrew the drawbar if your chuck is already in there and you want to exchange it. Then I suggest you go to Harbor Freight and you get one of these guys. You'll use one of the supplied wrenches to loosen this. You'll whack it a few times and it'll free up the chuck. Why would you want to do that? Because your mill should come with a few collets. Now there is controversy. Some people have said that you do not want to use the chuck for milling because it puts extreme force on the jaws and can ruin your chuck. I've used this chuck forever. I've had this mill for about 2 years now, and I've been using that for about 2 years. I've just recently changed out to this. I'll tell you about that. But you can use, your chuck will have run out, and the collets are going to be a lot better. You're going to get a 1/2 inch and a 3/8, and most of the tools, the end mills and things that you're going to use are all 1/2 inch and 3/8. They'll have like a 1/8 inch cutter, but it's going to have a 3/8 inch shank. So you'll remove the chuck and you'll insert the collet, and then you'll keep this in place to lock the spindle, and you'll tighten this up and snug it. Anytime you change anything in the spindle, you want to make sure you're absolutely clean up in the spindle, and the MT3 taper, likewise, whatever you're inserting, you want it to be clean. Do not wipe it down with a paper towel, because fiber particles will throw off your runout. It will create more runout in it. So that's basic on the chuck and the collets and how to lock and remove it. This guy is just for quickly getting into position. Like you saw, you can use it as a drill press if you have the chuck in there. You can engage it by pushing it in. Now you have fine tuning where you can read your indicator here and you can go 1/1000th of an inch at a time. If you're going to face something off, let's say you have this in the vise and you want to cut here, pull out a mill. Here's the mill. You're going to have this in here, you're going to move it over, and you're going to come down to height so that you're just below the bottom surface, and then you're going to lock. There's a lock here which now locks the spindle so it can't move, and now you're going to use your Y-axis to go back and forth and clean up the edge. If you're going to do top milling is when you really want to use the fine tuning, because you don't want to be able to dig in. You'll grab the work and things will start messing up on you. So what you want to do is you want to come down until you're close enough to the part where you can now latch it but not touch the part. Now you want to come down very slowly until you start cutting metal. Hang the end mill off the edge. Don't be full on. You want to be on the edge of it until you start touching, then you can back off. Now you can take the cuts that you want to do the surfacing with. So that's basic operation of that. To turn it on and to turn it on and off, it's simple. This is the emergency stop, and I use it. I have used it a few times. You want to make sure before you turn anything on that you're full counterclockwise. You have no RPMs at all. This switch, I'm not sure why they put this on here, because I basically use this to turn it on and off. I've always left this on. Release your emergency stop, then you can bring the RPM up slowly. Typically when I'm milling, I'm always halfway. The emergency stop too is if something jams, you can quickly hit it and your mill will shut down immediately. That's that, right? Okay. Axis movement is real simple. There's locks down here. There's two handles. You can lock the x-axis or the y-axis. On the mill. Okay, I think there's also just a no-brainer. This is just kind of a stop. You can put it in place so you can make sure your end mill cannot come down and cut into your vise. Okay, upgrades. A lot of upgrades are optional. Like I said, if you want to just do simple cutting, you don't really care about the finish, then you can use the mill as is. One of the first modifications I did was in here. Remove this cover and you'll see couplings that go like this. They're really sloppy. So what I did was I took it out and I pinched them in a vise and brought them together so I could get rid of the play. You can't really see it, but I pretty much got zero play here. The play is in here right now, which is in the worm gear, and there's not too much you can do about it. So that was one mod that made using the fine tune a lot easier and smoother, and I like that a lot. The second mod that I recommend is this whole drive belt pulley system. The original unit comes with plastic gears, and what happens is as you're trying to cut with the end mill, your cutter is doing this while it's spinning because of the play in the gears and because of the force. It's starting to chatter and it will affect your finish. Going to this drive belt system, which is sold by a place called the Mini Machine Shop, which you can find on the internet. It was a little bit over $100, but it substantially removes the noise and does make your cutting surfaces a lot nicer looking. I always run this on high. It defeats the knob on the left, which there is a high and low lever here, where if you're using the gear system, that's how you can switch between high and low speed. I'm always running on high speed. It works out good for me. So that's the next mod that I would recommend doing. It saves your eardrums quite a bit. The third mod is on the side. There'll be a big spring, which is trying to compensate for the weight of the head. And with the spring, as you come down, goes to the bottom, the spring is wound really tight, so it's real easy to move the handle when you're down low. When you come up high, the spring is really loose, so it requires a lot more force to bring it down. The Mini Machine Shop, or the Little Machine Shop, also sells a constant force piston retrofit kit where this one has a cable on it and there's two pistons that are inside the column, and you remove the spring and now it's taking care of the weight of the head, and since it's constant force you can easily move it up and down with your pinky. You cannot do that when the spring is in place. This particular one I made myself. I saw on a website somebody was saying you use 30-pound constant force pistons and they show you where to buy them. I bought them and they were not enough of force. I wound up keeping them. I couldn't return them, and buying 60-pounders. So there's two 60-pound pistons in here and it's making it really smooth. So that's the next mod that I highly recommend you do. As far as vices, there's a lot of different vices that you can use. Get one out of here. I've seen people use this type of vise, which is really a drill press vise. It's not precise at all. You can show basic how to square up your vise with a test indicator. But you can use this if you really don't care what you're making. It's just you're a hobbyist and you're just making some parts here and there for different projects. That's one type of vise. There's another type of vise which they call precision, which really isn't, and it's this guy. And the reason that this is a problem is because when you put your work in here, you're going to hold it down, you're going to bring this in, and you're going to start clamping. What happens is when the pressure gets tight enough, this lifts up. This will come up and it will cock your work. And you're going to have an angle if you do surface cutting on it. So I would not, like, this would be the next step up if you care a little bit more. This was my first vise and I did a lot of work with it. What I did though was I had put a piece of material in here, clamped it so that it went up, and then I ran an end mill down both sides. So now I can place the work in the top like that, and when it lifts up, I know I'm square. If you really care about super precision, this is the only vise to go with. That's a true machinist vise. And the reason is the lead screw is down here. This is a precision surface. It does not move. When you clamp down, your work is exactly where you clamped it and where you want it. You can dial indicate any surface on this and it's absolutely perfectly flat, level, square, everything. This, I think it was about $150, but this would be an excellent vise for professional type work. This is 3-inch wide and it's held just about everything that I need. Another upgrade is the digital readouts. They're called DROs. iGauge makes them. I think there's some other companies, but this is the most popular. I have X, Y, and Z in here. They'll tell me my movements to 1/1000th of an inch. They're accurate to 1/2,000th of an inch. If you're going to use them, mounting it on the X-axis is pretty easy. The Y-axis, you're going to have to do it at an angle and make parts. In the same way with the Z-axis, I have it on the side. The problem with it is the sensor itself is a little black box and it cannot be tweaked at all. You have to make sure that your mounting and the plate and the sensor do not have any forces on them at all. If there's any force, you will get erroneous readings. It will be wrong. And you can verify them, and I verify them by the extreme ends. You want to go to the extreme end and you'll need a dial indicator. No, you won't. You can use these. Go to the extreme end, zero out your DRO. There's a zero setting here. And then count using the indicator here, thousands. Move 10/1000ths of an inch, verify it says 10/1000ths. I would actually go 100/1000ths on this end, verify it on this end, verify it, and I would do it in the middle too. If the numbers aren't matching what you dialed in, you have stress on the sensor. So you got to really play with it and get everything absolutely straight. So that's on the dial indicators. The hardest one is the Z-axis, and I recommend, I've got the plate this way. I originally had it this way, and vibrations in the head were causing erroneous ticks or whatever, so it would all of a sudden just start counting by itself. So I mounted it this way, and that's eliminated the vibration sensitivity. All the cables too, you want to dress them as short as possible. You don't want them near this box because there's EMI, electromotive interference. It's a magnetic field that will bother this cable. Another thing that helped remove problems was there is a ground on this power cord for the unit. I've defeated the ground because of how this pulse width modulation motor runs. It's creating tremendous spikes in the AC line, and it's getting in the ground line, and the ground is the ground of the machine, so it was causing all kinds of other electrical problems. What else is there? That was that upgrade, the spring. I did, originally it comes with this plastic or rubber chip guard back here and in the front. They last for about a year. My first set lasted for a year. I ordered from Grizzly another one to replace it. They give you an entire sheet, that you can cut in half, and one half will cover the front and the back, and you have enough for the next year. I just went through the second set, and I figured let's just use leather, and so I just got leather in here. It's whiter because I've noticed before when I replaced it, there's a lot of chips down in here, and it's getting into the lead screw and it's causing problems. You'll be spinning, all of a sudden something binds and then it spins. So I highly recommend you widen it and you use the leather. This guy, a lot of times you're going to need light. This is a simple little LED light from IKEA. Low cost. I just have it stuck here and I can spin it around and I can put the light wherever I want. Because you'll find out that you're trying to see something and you can't do it. End mills. A lot of different kinds of end mills. There's that. There's titanium coatings, this, that. High-speed steel, HSS, is basically what I use. It's hard enough that it can mill steel, aluminum, brass, anything you want. The finishes on it don't really make that much of a difference that I can see. There's 4 flute, 3 flute, and 2 flute. If you're doing heavy cutting on aluminum, I would highly recommend the 2 flute, because the other ones are going to clog. It just hangs on to the chips too much. So this is a deep cutting aluminum end mill that I use. Carbides last longer. I mean, high-speed steel, everything always wears out over time. It's just a matter of time until you have to replace it. The carbide end mills will last a lot longer, but I have yet in 2 years and a lot of milling to wear out a high-speed steel end mill, even using it on steel. I do primarily do aluminum milling. So like I said, they come in all sizes. That's 3/8 shank, 3/8 shank, and dovetails. That's a 1/2 inch. So 1/2 inch and 3/8 is pretty common. So you know, what your end mill, the college that your end mill comes with, should be sufficient. You can see the difference here. This is, get that stand up. That's high-speed steel. This is carbide. I don't know if you guys can see in the camera, there is a color difference. So after a while you get good enough that if you go to swap meets or something and you spot an end mill, you'll be able to tell what it is by the color of it. Oh, I do recommend, there's a lot of indicators. Oh, I've got my test indicator over here. You're going to have to square it up. And to do that, you can buy different things, but I did make my own little holder. This guy goes into a 1/2 inch collet, and the test indicator sits on there, and you wind up running it down the table. To square up the vise, I tighten up one end pretty snug, the other end a little bit less. Then I'll hit 0 on this end, and then as I come down to this end, I'll tap the vise left and right until I get 0 reading. And that's the quickest way to actually square up your vise. The last upgrade I did was I was using the chuck, like I said, for all my milling and drilling purposes, and I was just dealing with the run out that was in it and the finishes, but I wanted to go up another level. I wanted to eliminate pretty much all the run out. So I found on Amazon, this is an ER32 collet holder. You can find on eBay the collet sets, really cheap. The entire metric set was something like $80. The Imperial collet set was $120, and it was like every size from a 1/16 up to almost an inch in 30-second increments. And this guy wasn't that expensive. But this pretty much gets rid of all the run out, and I don't have to worry about sizing or whatever, because I've got all the sizes, everything that fits it. Even if I want to drill, I can use this guy. So ER32, it's a beautiful upgrade that I did. It's improved the finishes considerably. And the last thing that I did, I don't know if it's in the camera view, is there's a power feed down there. It's a do-it-yourself homemade one. I do have a video on that if you want to watch. But before you do start milling, I highly recommend you watch my video on climb milling versus conventional milling. It is very easy to do something wrong and damage your mill, or worse, get hurt as parts come flying out of the vise. Like I said, there's a lot of force here. Now before you mill, you're going to have to tram it. And tramming is the process of adjusting it so that you're not tilted this way or this way. To do that, you're going to need a dial indicator. There's a lot of different ones. You can find a bunch on Amazon, different places. I've got a couple of different sizes. This is one in particular. I've made a little adapter where I can put this in the chuck when you have a chuck on there. And what you're going to do is you're going to rotate it from side to side. So you're going to come and dial in. Man, I gotta get this up farther. You're going to hit the surface down here, and then you're going to spin it around. You're going to hit the surface down here, and you're going to have this nut back here loose, and you're going to keep tapping until you get 0 here and 0 here, or the exact same number. On dial indicators, the test indicator and this one, you don't really care too much about the accuracy of it. You just want repeatability, because you're not going to be measuring actual thousandths with this. All you're doing is looking at a number. Okay, I hit this side and it's 62, and I hit this side and it's 63, so I'm a thousandth off. So this particular one wasn't that expensive. This is a Fowler. It came off of Amazon, and the test indicator that I show is a Turlen, I think you pronounce, yeah, Turlen. This also wasn't that expensive, and it really has been useful. Be very careful with this test indicator. You can force this. It's designed that you can bend the probe here to wherever you want. Do not go sideways. If you go sideways or you hit it, you will mess up the jewels that are in here, and now you'll have a worthless test indicator. The dial indicators are pretty indestructible, so you can put forces all over and you don't really cause any damage to it. So you're going to do the side-to-side tramming. Now the forward to back tramming, there is no adjustment, but what I did as an upgrade is there's a giant steel bar back here. It's drilled and tapped here in the back, and it's drilled and tapped below the nut on the back. The bar straddles the nut, and by loosening or tightening this screw, I can physically bend this entire column back to get it trammed. I'll use the same technique where I'm touching here and then I'm touching here, and I'll adjust it until I've got the same numbers on both sides. So that's the art of tramming. Well, I hope that helped somebody out. It's a fun machine. Don't be afraid of it. It's been a long road for me learning, so watch some of my other videos. You'll kind of see me as I upgrade and do mods. I've tried to cover everything that I've done. Feel free to leave comments. I will answer them. You know, I'm paying attention all the time. So join the group. Get a mill and a mini lathe. It's a blast. Till then, see you later.